Alright, in this video we will be doing some normal probability calculations. What do I mean by that? The word normal suggests a normal distribution or a bell curve like this. Number one, the Army reports that the distribution of head circumference among male soldiers is approximately normal, with a mean of 22.8 inches and a standard deviation of 1.1 inches. Draw the distribution. Alright, so draw yourself a sketch of a normal curve, like a bell curve. You can go ahead and put a line down the middle. So that's going to represent your mean of 22.8. So we'll go ahead and put this 22.8 because that's the mean. Now, go ahead and put a line almost to the end on the left and the right. And between those, I'm going to put two more lines, like say about here and here. And I'll do the same thing here and here. Now each one of these lines represents one standard deviation away from the mean. So notice that the standard deviation is 1.1. Okay, so if I add 1.1 in this direction, then this will be 23.9. Hello, darling. Do you need me today? Alright, let me know. If I add another 1.1, this is going to be 24. Well, actually 25, now that I think about it. Alright, and this last number, I think I'll switch back, will become 26.1. Alright, I'm just adding 1.1 each time. And similarly, going to the left, we go down, we subtract 1.1 each time from the mean, and we get these numbers. So there you have it. We have drawn the distribution. Alright, now, a male soldier whose head circumference is 23.9 inches would be at what percentile? That's a really good question. 23.9, is that on the chart? Oh, look, we're in luck. 23.9 is right here. Let us not forget the percentages that we have memorized. They go like this. Here we have 34% of the data. In this zone we have 13.5%. In this interval lies 2.35% of the data, and in this interval lies 0.15% of the data. And it's the same thing on the left side in reverse. At any rate, for part B it says a male soldier whose head circumference is 23.9 inches would be at what percentile? Well, the percentile goes like this. We can use these percents that I just described. So from the left side all the way to the middle, hint hint, the middle, what percent do I have over here? Well, of course, the entire left side is 50% of the data. So that just leaves this one extra interval to lead us up to the 23.9 head circumference. So that's an extra 34%. So put it all together and we're talking about 84% of the data. So if 23.9 is larger than 84% of the data, that means it is at the 84th percentile. Now, part C, what percent of soldiers have head circumference between 19.5 and 25 inches? Well, let's see. Let me just rewind this. Alright, 19.5 is right here, and 25 is right here. So between, we are talking about this interval right here. So part C is asking what percent lies in this interval. Well, all we have to do is add. Alright, take a closer look at this interval. In addition to the numbers that I just erased, there are 3 more numbers that we have memorized. We memorized that the percentage of the data that falls within 1 standard deviation of the mean is going to be 68%. So we know that this is 68% right here. Now, similarly, we memorized that if we go 2 standard deviations in both directions, like this, now we are looking at 95% of the data. Alright, so this would now be 95% of the data. Okay, so look how close we are to matching the yellow interval that we're looking for. In fact, we've already arrived at the 25 on the right-hand side. We just need to extend the left-hand side 1 more standard deviation, and that'll be it. So we can start with the 95% that we memorized, and we can just add on whatever this is. Do you remember what percent this is over here? Let's see. This is our 2.35%. Alright, so we've got 95% plus 2.35%. That's 97.35% of the data. Alright, next we have part D. A soldier has a head circumference of 22 inches. Find his z-score. Well, the z-score is, we'll just use the z-score formula, don't you know? The z-score is the value minus the mean divided by the standard deviation. We were already told that his head circumference is 22 inches. Which my daughter finds very funny for some reason. So we'll put in the 22 as his value. So now we just need the mean and standard deviation. Probably mentions that in the problem somewhere. Blah blah blah. Mean of 22.8, standard deviation 1.1. So there you go. Mean of 22.8. Standard deviation 1.1. Okay. Let's see, minus 22.8. Alright, I think I'm remembering that correctly. 22 minus 22. Yes. Okay, so we're facing a negative 0.73. Got to round up. Alright, so that was the answer to D. Now what about E? A soldier has a head circumference of 25.5 inches. Find his z-score and explain what the z-score means. Well, this is a bit redundant, but whatever. Whatever! Did the last one say explain? No. Alright, so once again, we will use his value, 25.5, minus the mean, 22.8, divided by the standard deviation, 1.1. Okay, 25.5 you say. Okay, that's 2.45. right, that is the standard, that is his z-score. This means that his head circumference is a good, it's almost 2.5 standard deviations above the mean. Alright, that means that his cranium is hella big. And look, you can see it here in the diagram. If you take a look, 25 is right here. So 25.5 would be somewhere over in this area. Okay, very far towards the upper end of this bell curve. So 25.5. Yes, 1 standard deviation, 2 standard deviations, over 2 standard deviations above the mean. That's a large head. So there it is in type. A z-score of 2.45 tells us that this soldier's head circumference is 2.45 standard deviations above the mean. Number 2, the distribution of the Wechsler Adult Intelligence Scale. I guess I just failed that intelligence test just then. WAIS scores for young adults is approximately normal with a mean of 110 and a standard deviation of 25. Alright, keep that in mind. If someone's score was reported as the 16th percentile, about what score would that individual have? Show your work. Well, first thing you should do is draw yourself a little normal curve like this. They said the mean was 110, so let's mark that down. Alright, let's get the other lines on here. Let's put one close to the end on the left and the right. Let's put 2 additional marks in between like so. And the same thing on the right. Okay, the standard deviation is 25. Each one of these lines represents a standard deviation. So if this is 110, looking at the 25 increase, then this is going to be 135. And this will be 160. And this will be 185. Going in the other direction, we'd have to subtract 25 each time. And that's going to give us 85 at -1 standard deviation. And then 60. And then 35. So, now looking at the numbers that we have memorized, alright, numbers like, well, we've just plain memorized that this interval right here represents 2.5% of the data, and then this interval right here is 13.5% of the data. So if you do 13.5 plus 2.5, what you get is 16% of the data. So the bottom 3 intervals here represent 16% of the data. Okay, so that means that 85, alright, a score of 85 would be at the 16th percentile because it's just above 16% of the data. So that's what it means to be the 16th percentile. Alright, answer the same question for the 97.5th percentile. Alright, let's go back and use the same graph again. If I go from the left all the way up to 110, surely you see that so far I am looking at 50% of the data. Okay, because it's going up to the middle, so far that I should use green. So far it is clear that we are looking at 50% of the data. I can do better than that. 50% of the data. Now we are shooting for 97.5% of the data. So the next interval over is 13.5. So if I take my 50% and I add 13.5, wait, I lied. 13.5 is the next interval over. All right, this is 34% right here. All right, this is 34% of the data in this interval. So if I add that on, 50% plus 34%, that becomes 84% altogether. All right, so let me redraw. So hopefully you hear me saying that if I extend this one more interval, one more standard deviation, now we are looking at 84% of the data. Now again, we are shooting for 97.5, so we keep going. The next interval over is 13.5% of the data. So if I take my 84 and I add 13.5, what do I get? Oh look, 97, bless you,
Thank you.
0.5, 97.5. That's what we were trying to get in the first place. Okay, so we are pretty much done in that case. So we saw that if we extend this one more interval, now we are looking at 97.5% of the data. Okay, that makes 160, all right, where we land, the 97.5th percentile, because 160 is the number that is above 97.5% of the data. All right, that's it for number 2B. Suppose scores on a company test are normally distributed. Workers with scores of 130 were 2 standard deviations above the mean, and workers with scores of 30 were 3 standard deviations below the mean. What are the mean and standard deviation of the workers' performance scores? I think we are going to have to set up 2 equations and use substitution. We're going to have to solve a system of equations. Okay, so let's see. First of all, workers with scores of 130. All right, let's build our first equation. Scores of 130, 2 standard deviations above the mean. Okay, let's set up an equation for that. First of all, 2 standard deviations above the mean, that means a z-score of 2. So remember the formula. The z-score is equal to the value minus the mean divided by the standard deviation. So let's set up our first one of those. 2 standard deviations above the mean, that means the z-score is 2. So I'll put that right here. The value, well, we're talking about workers with scores of 130. So that's the value. Okay, the regular value is 130. Now we don't know the mean. That's one of the things we're trying to find. And we don't know the standard deviation either. We're trying to find that too. So here is our first equation. Okay, now, so here comes the second equation. So the second equation is, let's see, workers with scores of 30 are 3 standard deviations below the mean. 3 standard deviations below the mean is a z-score of -3. -3 means 3 standard deviations below the mean. Okay, and these are workers with a score of 30. So that's why we're going to do 30 minus the mean over the standard deviation. So we have 2 equations and 2 unknowns. We should be able to do substitution and solve this thing out. So here we go. What I would like to do is get rid of the fractional aspect of this by I'm going to multiply both sides of the equation by the standard deviation. That way these standard deviations cancel out. I'm going to do the same thing over here. Standard deviation, standard deviation. Okay, these are going to cancel out. So that is going to give me, all right, 2 standard deviations is equal to 130 minus the mean. All right, I'm going to get the mean by itself by subtracting 130 from both sides. So that's going to give me 2 standard deviations minus 130 is equal to negative mean. Now I'm going to divide everything by -1 in order to change all these signs. So that'll give me negative 2 standard deviations, whoops, not equal to, plus 130 is equal to positive mean. Alright, so here I've got the mean by itself and it's equal to this expression. Now doing the same thing over here, I've got -3 standard deviations is equal to 30 minus the mean. So when I subtract 30 from both sides, I get -3 standard deviations minus 30 is equal negative mean. Then I divide everything by -1, just like I did over here. Got to get rid of this negative sign. That gives me 3 standard deviations plus 30 is equal to the mean. So I have this. Alright, the mean equals this, the mean equals that. That means both of these are going to be equal to each other. Or you could think of it as taking this and substituting it in here. Either way, you're going to wind up setting this equal to this. Alright, so I'm going to do that over here. So 3 standard deviations plus 30 is equal to -2 standard deviations plus 130. Okay. When I see the variable on both sides, I want to put those together. So I'm going to add 2 standard deviations to both sides. These are going to cancel out, and that's going to give me 5 standard deviations plus 30 is equal to 130. So then I subtract 30 from both sides. Okay, so that's going to give me 5 standard deviations is equal to 100. Then I will divide both sides by 5. Alright, so that's going to give me that the standard deviation is equal to 20. Alright, so that's one of the things I was supposed to find. Standard deviation is equal to 20. Now I'm still looking for the mean. Well, I have 2 different expressions for the mean. I think I'll use this one. The mean is equal to 30 standard deviations, 3 standard deviations plus 30. Okay, so I might as well just do that over here. Alright, the mean is equal to 3 standard deviations plus 30. Did I get that right? Yeah. But now I know that the standard deviation is 20. So I could just take this 20 and put it in for the standard deviation right there. So that means that the mean is equal to 3 times 20 plus 30. That's 60 plus 30. That's 90. All right, so the mean is 90 while the standard deviation is 20. And that's what we were supposed to find. What are the mean and standard deviation? Number 4, David's standardized score on the math part of the SAT was 1.5. The distribution is symmetric, unimodal, mean of 510, with a standard deviation of 80. What is David's actual SAT score? Okay, I think I need to zoom out a bit. Okay, so again, we're using the formula. We're using this formula. The z-score is equal to the value minus the mean divided by the standard deviation. Okay, but this time they gave us the standardized score. In other words, the z-score is 1.5. And that's going to equal the value, which in this case is the SAT score, minus the mean. Alright, the mean is 510 with a standard deviation of 80. Alright, so if we solve for x, that'll be his actual SAT score. Okay, so that's why we can just multiply by 80 on both sides. That's 120. Alright, that's a horrible 5. OCD! Okay, so that's going to, I'm going to add 510. So that'll be 630. So there is his SAT score. Alright, that was number 4. Number 5, Sarah's standardized score on the math part of the ACT was 2.5. Okay, so again, I'm betting we're going to be using this formula. The z-score is the value minus the mean divided by the standard deviation. So they told us that her standardized score was 2.5. That's the z-score. So we're given the 2.5. Alright, it's symmetric, it's unimodal. Alright, it's a bell curve is what they're saying. With a mean of 18 and a standard deviation of 6. Okay, mean of 18 and a standard deviation of 6. What was Sarah's actual ACT math score? Well, again, that'll be the x in this equation. So we can just multiply by 6 like I did before. That way these will cancel out. So that's 15. And then we will add 18 to both sides. So that's looking like 33. So that would be her actual ACT math score. Alright, and I think that was the last question of this assignment. Therefore, here endeth the lesson.